All right, so here we go. Awesome day. This lesson went really, really well. The last 2 hours, I would say the best that I've had it gone for the past couple of years I've taught it. So hopefully, it'll go well for you guys too. Taylor Martinez, we hope you're feeling better, and we look forward to seeing you back in class soon. Shifted parabola. Okay, so. We're going to write down a bunch of equations and we're going to tell the difference between them. Bryn asks, could you cut this out? Yeah. You can dissect your notes however you want, put them on another sheet of paper. But what you can't do is take the example problems that we do and have those on the test. Okay? Or on your sheet of notes. So, here's a shifted parabola. Y equals a times x minus h quantity squared plus k. Is that vertical or horizontal? That's vertical. So the horizontal one would be x equals a times y minus k quantity squared plus h. An ellipse is good. Oh, what's the vertex of each of these? H. Okay, very good. That's what we got. Then we move to an ellipse. An ellipse would be like x minus h quantity squared over a squared plus y minus k quantity squared over b squared is equal to 1. That's stretched horizontally. How does it change if it's stretched vertically? The a is under the y. So x minus h quantity squared over b squared plus y minus k quantity squared over a squared equals 1, centered at hk. So if you need to make a note to yourself that for ellipses, a is the larger value, then do that. Today's Tuesday. Test is Friday. Shifted hyperbola. What's different about the hyperbola equation? It's got subtraction. X minus h quantity squared over a squared minus y minus k quantity squared over b squared is equal to 1. Is that a horizontal hyperbola or a vertical hyperbola? We have two guesses, vertical and horizontal. Which is it? Why is it horizontal? Because x is positive. So if you want to make it so it's vertical, I'll make the y positive. Y minus k quantity squared over a squared minus x minus h quantity squared over b squared is equal to 1. Again, the center is at hk. Now that's nothing new. We've written those down before. We're just doing it again so we can be familiar with all the formulas because we're going to use them today in our notes. What is new is this, how to tell the difference between each one. So you tell me, what makes the parabola equation unique compared to the others? No division, okay. What'd you say? Okay, no fraction. What else? What else? Okay, there is a variable on one side. Yeah, the other two are equal to 1. This one's got a variable. What do you notice about the x and y values in the parabola compared to the ellipse and the hyperbola? They're not both squared. So, here's the key. With a parabola, you will have x and y squared, or you will have y and x squared. One of them will be squared, the other one will not be squared. Okay, that's the difference. in an ellipse, both are squared, yes, no? Yeah. So you're going to have an x squared and a y squared. Not only are both squared, but both are positive. Okay, the hyperbola, you have x squared and y squared, but one is negative. So you'd either have x squared and negative y squared, or you had negative x squared and positive y squared. That's the difference. Those are the indicators that you have to look for. And that's if they're on the same side. I mean, if you got x squared on one side and y squared on another. For example, x squared plus 2 equals y squared minus 9, okay, plus 9. You know, you might look at that, you might say, well, I got an x squared and a y squared, they're both positive. But they're on opposite sides. What happens when you add the y or subtract the y squared over? Then it's negative. So this is a hyperbola. Okay? You know, we're talking about when they're on the same side over here, okay? So, question, Quinn? You'd be taking the square root. Oh, good question. So the study of conic sections goes a lot further than what we're going to go with, and there's things called degenerate conic sections, and those are some where you really can't get a graph out of them. It has to do with some complex analysis as well. So you can read about it in your book. If we had more time, we'd do it, but and you'd never use it again in your life. Well, maybe you took like a complex analysis course in college. So I think I never took a complex analysis course. One I wish I would have. Didn't have time. Too many crush cans. Grant, you didn't even laugh. I thought for sure I'd get you there. You didn't even believe me. You're like, that ugly face? No way. That's what you were thinking, wasn't it? See, now I got you. Okay, here we go. Place the following conic sections in its standard form. Graph the conic section and identify all the important characteristics. We will do this today, okay? We will not actually write down all the important characteristics for the sake of time. Not because you won't have to on the test or the study guide, but simply for the sake of time. We just don't have time to do it all today, okay? So, we're going to do the most important part. Once we sketch the graph, you could go back and write everything down. I know you could do that. Alright. See if you get it. Is this going to be a parabola, an ellipse, or a hyperbola? Hyperbola. Why? Both are squared and one is negative. Very good. So we know this is a hyperbola. So as we go about our equation solving process or writing it in standard form, you know what your end goal is. Okay, this is your goal. To make it look like, you know, that form over there. That's what you want to end up with. So we know it needs to be equal to 1. That's where we're headed. Notice how these have completed squares. X minus h squared, y minus k squared. This doesn't have any completed squares yet. So we're going to have to go through and complete some squares. I'm going to factor out a 9. 9 times x squared minus 8x. Close my parenthesis. And then what can you factor out of negative 16y squared and negative 32y? A negative 16. You get y squared plus 2y, careful about that, equals 16. Everybody understand my first step? What number do you add to complete the square? 16. You take 8, divide it by 2 to get 4, square it to get 16. What did we really do to the left side? We didn't just add 16. We added added 9 times 16, didn't we? Look at that, by completing the square, you added 9 times 16. The true value of that isn't 16, it's 144. So whatever 9 times 16 is. So if I added 144 to the left side, I have to add 144 to the right side. So that's a completed square. How about this one? What do you add to complete the square? 1. You didn't actually add 1. What did you do? You subtracted 16. So if I subtracted 16 from the left, subtract it from the right. Ain't that pretty? Alright. Wow, that's a lot of stuff, huh? 9 times x minus 4. Quantity squared. Minus 16 times y plus 1. Quantity squared equals 144. Okay, we're getting closer to the form that we want. But it has to be equal to 1. So therefore we divide it out. What is 9 over 144 reduced to? 1/16. So x minus 4 quantity squared over 16 minus, what is 16 over 144 reduced to? 1/9. Equals 1. Is that in a form that you recognize? So we had a goal in mind from what we set out. We identified it's going to be a hyperbola. Then we went through the completing the square process. Do you now see why I spent so much time for a semester trying to teach you to complete the square? So it would help out here. So we've got that piece, okay? And now we're not going to identify all the characteristics as we write them down, but we're simply going to graph it. So let's sketch that graph. And I trust that if you're able to sketch the graph with me, you would be able to then write down the characteristics. Question? No dumb questions. Like here? Excellent question. Here's what I do. I see that you got this, it's shifted over 4 units, Sadie. See how it's shifted 4? And I'm going to have to go 4 more in each direction. So it's already shifted 4, and then I'm going to have to go 4 more because you got 16 underneath here. This is shifted 1, and then I go 3 units in each direction. So I can see that 8 would be the furthest that I would go from the center. So I think 8 is you could go. I usually go a couple more units past that, like 10, but I think that's reasonable. So that's how I determine my numbers. Good question. I've never talked about that. I've just done it. So okay, what's the center? 4, -1. Now I make my box. How many units do I go left and right? 4. How many units up and down? Yep, 3. And make my box. By the way, I never did watch a movie with my wife the other night. No, I did. We ended up going over to my in-laws, and we watched Despicable Me with the kids. You guys like that movie? The Minions? I like the Minions. Have you guys seen Despicable Me 2? Is that a good movie? Alright, I gotta check it out. Okay, I drew my asymptotes. I got my box. Do the vertices go on the top and bottom, or do they go on the right and left? They go on the right and left because this is a horizontal because the x is first, or because the x is positive. So very good. So I'm going to put my vertices are going to go on then the left and right of the box. I can draw my shape. What's the only thing I don't have on my shape yet that I need? Foci. And the way I, good, because the equation for focus points, in order to find C, we do Pythagorean theorem. C squared is A squared plus B squared. So we got A squared plus B squared is 25, square root is 5. So you go 5 units from the center. Bada bing, bada bam. Graph is done. Scott. Well, yeah, but here's what people do. They see the 16 and the 9, and I'm the same way. I'm like, well, 25, right? 5. You know, you're like, so it's a great, you know, nice 3, 4, 5 triangle, right? Here's the problem. That if that's an ellipse, well, then it's got to be subtraction, so you end up with the square root of 7, right? So people make those assumptions on a test, which aren't always right. So that's the only thing to be careful of. Okay. What do you think? Worse than you thought? Better than you thought? You know, somebody said last hour. They said, "I thought you said that this was going to be difficult." I was like, "Wow, well that's great because you don't find it difficult." And their argument was, they said, well, we already know how to complete the square. We learned that first semester. And we learned how to do shifted hyperbolas yesterday. So they said this really isn't anything new. And they're absolutely right. It's putting it all together. But I just think for most students, when you put it all together, sometimes, well, I mean, it's not new. It's just we're putting it all together into one. You know what I mean? I guess what's new today is you're, you know, taking a problem like this and putting it into a form. But as long as you know how to complete the square and then graph it, then you're good to go. Yeah. Right. The deal is that today I'm just going to do it to save time, and then on the test, I don't want to write down asymptotes here because then you would know it would be a hyperbola. You know what I mean? Not much fun in the game there, is there? So, all right. I know, that's what you think. You think fun game when you think mathematics. So, all right, here we go. All right, any other questions? Okay, which shape is that? Parabola, Wyburn. Very good. So you got the y and you got the x squared. So we got one element that's squared, therefore it's a parabola. Parabola. Okay. So, is this going to be a y equals or an x equals? Y equals. So therefore, we're going to have a completed square for x squared. So we got x squared minus 4x equals 8y minus 28. What do you need to add to complete the square? Good try. 4. Take the 4, divide it by 2 to get 2, square it to get 4, so 4 is what we add. What's the true value of that 4? 4. So you need to add 4 to the opposite side. X squared minus 4x plus 4 factors 2. X minus 2, quantity squared, equals 8y minus 24. So we have our completed square. Now we just need to solve for y. So we're going to add our 24 over x minus 2 quantity squared plus 24. Divide by 8. Divide everything by 8. So if I divide by 8, what number is going to go in front of my x minus 2 quantity squared? 1/8. So is this vertical or horizontal? Vertical. Up or down? Up. Vertex. 2, 3. 2, 3. Let's draw it. You divide it by 8, but you still got to divide the 24 on the other side first. If you're dividing everything by 8. So you have to divide the whole side by 8. You told me the vertex was 2, 3, so I'm going to plot that over 2, up 3. Beautiful. Axis of symmetry. Is it going to be horizontal or vertical? Vertical because it's a vertical parabola, so therefore your axis of symmetry will run right down the center of that vertex. I'm sorry, run right through the vertex, center of the parabola. Never stated. Okay, well, now I guess I need my focus and my directrix. How do you find the focus and the directrix? A, or 1/8, is equal to 1 over 4p. That's our equation. You can look at that and realize that p is equal to 2. So I move 2 units from the vertex to get my, what do we call that point? Focus. I move 2 units down for the directrix. And the directrix is a line. Is it going to be a horizontal line or vertical line? Horizontal because it's perpendicular to the axis of symmetry. Runs right through. The focus. What line runs through the focus? Lattice rectum. The length of the lattice rectum is equal to the absolute value of 4 times p. What's 4 times p? 8. So 4 units on each side. So that's my lattice rectum. Now I can start at my vertex and go through the endpoints of the lattice rectum, and I have my shape. What do you think? Not too bad? Okay, how about this? If there's a part that would catch you up in this process, what would it be? Would it be completing the square? Would it be identifying P? What is it? Yeah. Okay. No, that's perfectly all right. If you could come up with the equation, then I guess what I would do is this. Let's say, for example, that you had x equals negative a times x minus h, or y minus k, quantity squared, plus h. You know, if you came up with a negative value as x, then what I would do is I would, on my sheet of notes, I would just draw a general sketch of a parabola. This one goes to the left. And I would just put my focus here. I would put my directrix here, and I would, draw my axis of symmetry, and I would draw my directrix, and I would just have a note by that saying, if it's x equals and it's negative, then this is the shape I want. I might draw 4 of those shapes. One for x equals negative a, one for x equals positive a, one for y equals positive a, and for one y equals a negative a. Because that's going to be left, right, up, and down. And so then you can kind of, I think once you get the picture in mind, it might be easier to go from there. So, any other thoughts? Okay, let's do the last problem. What shape is number 3? It is an ellipse, but why? Yep. Squared, squared, both positive. This is an ellipse. Well, I shouldn't say that. What other conic section could you have 2 squares and both be positive? A circle. The difference is this is not a circle because a circle is stretched evenly in both directions. Because this has a 2 on the x and a 1 on 2 on the x squared and a 1 on the y squared, it's going to be stretched differently in each direction. If it was a circle, there would either be a 2 on the y squared as well, or both would just have a 1 in front of the x squared and y squared. So that's the difference. You're not tested on circles, okay? We already did that a while ago. I just want you to know that they are part of the family of conic sections. So, all right, let's do it. What can you factor out of the x's? A 2. X squared minus 6x. Y squared plus 6y. I put negative 26 over here because I don't like it on that side. What do you add to complete the square? What's the true value of that 9? So we add 18. And what do you add the next one? 9. True value is 9. All we did. Complete both squares. 2 times x minus 3 quantity squared plus y plus 3 quantity squared equals 1. What are you thinking? What don't you like about it? You don't like the 2 in front. Divide by 2, then you're going to get a 1/2 over here. It has to be equal to 1. So it's equal to 1, but you don't like the fact you have the 2. You're right. We can't tell what we want to learn about it by the 2 in front. So this is an example of an ellipse. This is a good form for an ellipse. But if you want to tell something about it, it's got to look just a little bit differently. Instead of multiplying by 2, what's the same thing as multiplying by 2? Dividing by a half. So x minus 3 quantity squared over 1/2. Those are the same expressions. Plus y plus 3 squared over 1 equals 1. Those are the same. So is this stretched more horizontally or vertically? Vertically, because the bigger number is under y. So the number 2, so this is the number 2, right? 2 is the same as 1 over a half. And so all I did is I just made this look differently. I don't want to divide everything through by a number. Okay? These are equivalent in value. I just rewrote it just as I would maybe choose to rewrite the number 4 as, say, 8/2 or something. So all I did is rewrote it in a way that I can now glean some information about it. Since the a value is bigger underneath y plus 3 squared. This is stretched more vertically. So my a value is 1. How would you find the b value? What would you do? To find the a value, you took the square root of 1. So to find the b value, you take the square root of 1/2. Square root of 1/2 is the square root of 2 over 2, and it comes out to be 0.7071. And the only way I know that is because it comes up all the time in trigonometry. You'll see it in the next month quite often. In order to find c, what equation do I use? C squared equals a squared minus b squared for ellipses. A squared is 1. B squared is 1/2. What's 1 minus 1/2? 1/2. So c is going to be the square root of 1/2, which was the same thing as b. It's an isosceles ellipse. That's an interesting thought. It's the same thought I had. Never put the two words together, but cool. I like it. All right, let's sketch a little graph. What's the center? 3, -3. How many units vertically? 1. How many units horizontally? 0.7071. Just do a little guesstimation here. And that's my ellipse. Let's have a little guy. And then for the foci, do I travel vertically or horizontally? Vertically, because that's the direction it's stretched. So I'm going to travel 0.7071 in both directions. And that's my graph. That's it. So you can see we don't have a lot of time left. That's why I didn't want to write everything down. Even saving a couple minutes here or there matters. So today's assignment, I've got 4 problems for you to do. I told you it would be best if you could come to class tomorrow and really only have this assignment to work on. And maybe this assignment won't take you as long as what I thought. I did cut down on the number of problems from last year, only because I really like you guys. And the problem is that as you see less examples, you maybe don't have the same amount of practice. So I'm going to encourage you, if you want more practice, just go to this section and just try more of those problems. See if you can get them right. So your learning is in your hands. The assignment is just kind of the bare minimum, so to speak. I don't have any extra stuff for you. So if you want to practice more, practice more. Try some of those other problems. So again, tomorrow's a work day, and then study guide all day Thursday. Test on Friday. That's it.